Today we are going to study about electricity. You may have used an electric torch when you're going out at night. You can get more light when using an electric torch with more cells. Now you must have noticed your father or mother when they want to increase the brightness of the torch, what do? They add more cells into the torch. Now, you can use a line of bulb to illuminate the environment in ceremonial occasions. In such occasions, color bulbs can be used to increase the attraction. The bulbs illuminate because an electric source sends a flow of electric charges through them. Such a flow of electric charges is known as an electric current. Now, bulbs illuminate because there's a flow of electric charges goes through them. So before we continue this lesson, let's learn what is the electricity and how it generates. Now, before that, let me explain. You must have had some problem with the cell and the battery. Let me explain the cell difference between the cell and a battery. Cell and a battery. Now, this is a cell and this is a battery, and then we are going to study difference between a cell and a battery. Then this is we can call this also a battery, but we can't call this is a cell. Battery means a cell is a singular unit that produces electric current. Cell is a singular unit, one. It produces electric current. A battery is composed of many cells. In this battery have got many cells inside. A cell can be a battery. This can be a battery. A battery cannot be a cell. This cannot be a cell. The symbol of a cell is this. The symbol of a battery is this. Now this long line denote positive charge, and this positive terminal, and the short line denote negative terminal. Let's learn about terminal. This is a cell and also can call a battery. Now here the positive terminal and here the negative terminal. Let's go back to the lesson. We have stopped at this electric current. Now before we continue this, we should know what is electricity and how it is generated. What is electricity? Any appliances that we use in our daily life, such as household appliances, office equipments, and industrial equipments, almost all of those things take electricity. Therefore, we should understand electricity. Where does electricity come from? All matters are made up of atoms. What are atoms? Atoms are the smallest part of an element. They are composed of nucleus and electrons surround nucleus. This is the nucleus, and electrons surround nucleus on our orbit. Every atom has an equal number of protons and electrons, so atoms have no overall charges. Now, in this nucleus have got protons and neutrons. The number of protons equal to the electrons. So, therefore, there are no overall charges. Overall charges mean, I will explain it to you next slide. Elements are identified by the number of electrons in orbit around nucleus of atoms and by the number of protons in nucleus. Nucleus is made up of protons and neutrons, and the number of protons and neutrons are balanced. Neutrons have no electric charge. Protons have positive charge, and electrons have negative charge. A positive charge of protons equals the negative charge of electrons. So that means the proton is positive and electron is negative, and proton and electron have equal amount of protons and electrons there. So therefore, then the positive and negative form a neutral atom. Electrons are bound in their orbit by attraction of protons. But electrons in the outer band can become free of their orbit by some external force. These are referred to as free electrons, which move from one atom to the next. Electron flows are produced. Now you can see here the nucleus, and here are the electrons. These electrons um, goes around this nucleus on a band, like in their orbit, right? It's like solar system, right? So then, so then, what makes this electron stable and it doesn't go off from the orbit? Because this nucleus attracts the electrons. In this nucleus, it has got protons. Then proton is positive, electron is negative. So the positive attracts the negative electrons. Therefore, this attractional force keeps them on this band, yes, orbit. So it is similar to the planets we see in the solar system. These planets doesn't go off from the orbit because due to the attraction of the sun, due to the attraction of sun, gravitational force of sun and the planet. These are the basis of electricity. Now, when I if there is a atom, it have got more shells around it, around nucleus, more bands. Then the outer bands are not so stable because the attractional force is lesser than the inner band. So then, therefore, then these electrons are not stable. If we give a force, it can go out of the orbit, out of this orbit. Materials that allow many electrons to move freely are called conductors. That materials allow many electrons to move freely are called conductors. And materials that allow fewer free electrons to move are called insulators. That means the current passes through the conductors than the insulators. All metals are made up of atoms that have electric charges. Therefore, they have electric charges. As I explained you before, now here the carbon atom, positive proton and negative electron and no charge neutron. For the matter that has a balanced number of protons and electrons, the positive charge force and the negative charge force are balanced. As I told you, anyway, the atoms are neutral because it doesn't have an overall charge. It is called neutral state of an atom. The number of protons and electrons remain equal. Everything is made up of atoms. Even our body, table, chair, everything is made up of atoms. But those are neutral atoms. Neutral state of an atom. The balance of positive charges and negative charges. Now the positive charge, like charges repel, positive repel, doesn't attract. Then the negative doesn't attract, repel. Now the positive and then negative, it attracts. Unlike charges, attracts. That's how these electrons moves around the orbit without goes off from the orbit because due to the attractional force from the protons to the electrons, positive and negative. Static electricity represents the situation that all things are made up of electric charges. For example, the rubbing of material against another can cause the static electricity. Free electrons of one material move forcefully till they are freed of their orbit around nucleus and move to another. Now the electrons are anyway stable now, but we can move it forcefully. Till the electrons move, we can rub it. So once the electrons move, when we let the electrons to move forcefully, then it causes static electricity. Electrons of one material decreases, it presents positive charges. At the same time, electrons of another increases, it has negative charges. Now, when we rub a comb or something on a table, so then the comb gets the electric charges. It's like this. Now here the positive charges from here positive and negative is equal in an atom. So then when we rub the material, what will happen? It gives a vibrational force, bouncing vibrational force, and these electrons start moving around, start vibrate, and it goes off from the orbit and start moving. So then they hear the negative negative electron and the positive proton. Then the electron negative will start moving when we give a force, external force. Then it goes off from the orbit to another atom. So then what will happen? Another atom or material. Then what will happen? Then the negative level is decreases here because less electricity. Once electrons goes away from the atom, then there will be more positive proton. Then this material gets positive charge. Then this material gets negative charge. This atom gets negative charge. Why? Because negative electrons has gone there and it has increased the negative value, negative charge of electrons. In general, charge producing of the matter means the matter has electric charge. It has positive and negative charge which is expressed in Coulomb. Example, cut several small pieces of dry paper and place them on a table. Rub a plastic pen against your dry hair and hold the pen close to the piece of paper. What can you observe? You can observe how the piece of paper are attracted to the pen. When some objects are rubbed, electric charges are generated on them. Electric charges generated on the surface of objects by rubbing are called static electric charge. A current of electricity is a steady flow of electrons. Current of electricity is a steady flow of it. Is a steadily flowing of electrons. When electrons move from one place to another round a circuit, they carry electrical energy from place to place, like marching ants carrying leaves. Instead of carrying leaves, electrons carry a tiny amount of electric charge. Now let's go back to the lesson. Let us find out now the electric current flow only when go back to the electric current. The path of an electric current is called an electric circuit. A voltage should be supplied to a circuit for the flow of current. Voltage is supplied by an electric source. Now, when the voltage has to be there to pass the flow of current. Electric current flows only when an electric source is connected in a closed circuit with conductors. I have taught you what is conductors and insulators. Then through conductors, electric current passes easily. A switch can be used to open or close circuit when necessary. Let us find out about making a circuit using various electric components and how they work. Various methods of connecting cells and bulbs. There are two methods we are going to teach: series cell system and parallel cell system. Let us find out methods of lighting a bulb using several 1.5 volt dry cells. 3 identical filament bulbs, 6 dry cells, a switch connecting wires, a voltmeter. First connect one dry cell with the bulb. First connect one dry cell with the bulb and switch as shown. Switch switch as shown in figure 10.1 connected to the voltmeter to measure the voltage across the bulb. Voltmeter is there to measure the voltage across the bulb. Then connect two dry cells with another bulb and the switch shown in figure 10.2. This two dry cells connect to the bulb and the switch. After that, connect three dry cells with the third bulb and the switch as shown in figure 10.3. Now close the switch of all three circuits at the same time. Switch on same time and switch off also same time. Compare the brightness of the bulb and record the voltmeter reading. Now compare the brightness of the bulb and record the voltmeter reading. It can observe that the brightness of bulb increases when more cells are connected, as in figure 10.1 and 10.2 and 10.3. Now, when you connect more cells, then the brightness of the bulb also increases. When the number of cells are increased, the voltage increases and the current also increases accordingly. When the number of cells are increased, the voltage increases and the current also increases accordingly. When the required voltage for an electric equipment cannot be supplied by a single cell, several cells are connected. Now, if we use some electrical equipment, if the voltage is not enough to work, so what we have to do is add some more cells to get the required voltage. In this connection, the negative terminal of one cell is connected to the positive terminal of the next one. Negative terminal of one cell is connected to the positive terminal of other one. Negative then the positive then again the negative terminal and the positive terminal is connected. Now here is like this positive, negative, positive, negative. So with negative terminal, you have to connect the positive terminal. Then negative terminal, you have to connect the positive terminal. In this connection, the negative terminal of one cell is connected to the positive terminal of the next one. The negative terminal of the second cell is connected to the positive terminal of third one, and so on. When two or more cells are connected, one after the other, as described above, it is called a series connection. These are called series connection. Therefore, such a cell system is known as series cell system. A combination of multiple cells is known as battery. A combination of multiple cells is called battery. If it is single one, then we can call a cell. 2 and 3 cell combinations shown in figure 10.5 are examples of battery. Parallel cell system. Another method of connecting the cells in a cell system, battery, is shown in figure 10.6 and 10.6a and 10.6b. Is another method of connecting the battery cell. Then this is parallel system. We learn series cell system, and this is parallel cell system. In this connection, positive terminal of all the cells are connected to one point and the negative terminal of them are connected to another point. Positive terminal of all the cells connected to one point, negative terminal connected from another point. A connection like this is called parallel connection. Such a cell system is known as a parallel cell system. Let us do the activity 10.2 to study about parallel cell system. 6 dry cells, 3 identical filament bulbs, 3 switches and connecting wires. First connect one dry cell with a bulb and a switch. One dry cell with a bulb and a switch. Bulb and a switch. Close the switch and observe the brightness of the bulb. Then connect other cells to the two bulbs and switches as shown in figure 10.8 and 10.9. Now use another cell and add it parallelly and connect it and see, observe the brightness of the bulb and another cell and observe the brightness of the bulb and compare the brightness of the bulb. The bulbs will light with more or less the same brightness in all three instances mentioned above. Thus, the current flowing through the bulb should be equal when cells are connected in this manner. Now we can see there is no big difference the brightness of these bulbs among these bulbs. So it's all equal. Then the current flowing through the bulb should be equal. The current also that goes through the bulb must be equal. When cells are connected in this manner, each cell supplies less current, but the collection of current supplied by cells is equal to current supplied by one cell. Therefore, when cells are connected parallelly, bulb can light for a longer time, thus cell can last for a longer time. Then, what is the advantage of this parallel system? The bulb can light for a longer time, thus cell can last a longer time. When a current should be supplied for a longer time to an electric equipment, parallel cell system are used. When current should be supplied for a long time to an electric equipment, parallel cell system are used. I will explain the advantage of these two systems. We'll find out what is the difference between the parallel system and the series system. What is the difference between parallel and series connection? In a series connection, in a circuit, every device must function for the circuit to be complete. If one bulb burns out in a series circuit, the entire circuit is broken. In the series circuit, if one bulb goes off, then the whole circuit will be broken. Bulb burns out in a series circuit, then the entire circuit is broken. The biggest advantage of a series circuit is that you can add additional power devices. You can add additional power devices. So the biggest advantage of a series circuit is that you can add additional power devices, usually using batteries. This will greatly increase the overall force of your output of giving you more power. You can also connect batteries in series or parallel. Now, if we want to increase the brightness of this bulb, what we should do is add some more cells to this circuit. Then the brightness of the bulb will be increased. This will, when batteries are hooked up in series, the voltage is increased. Voltage also increased. For example, two 6-volt batteries connected in series produce 12 volts. An example of parallel circuit is the wiring system of a house. An example of a parallel circuit is the wiring system of a house. A single electric power source supplies all the lights and appliances with the same voltage, or the lights and appliance with the same voltage can be powered. If one of the light burns out, current can still flow through the rest of the lights and appliances. If one light bulb goes off, even current can flow through the circuit. When batteries are hooked up in parallel, the voltage remains the same. When we add more batteries, even the voltage remains same, but the power or available current is increased. We can increase the current. This means that the batteries would last longer. For example, two 6-volt batteries connected in parallel would still produce 6 volts, but the two batteries would be able to power a 6-volt device twice as long as single battery. Hope you understood. 6-volt batteries, if you add another 6-volt battery, but it doesn't change. That is 6-volt battery, but two batteries should be able to power a 6-volt device twice as long as single battery. Cells in series. The electric potential given to a single electron by a dry cell has an average voltage of around 1.5 volts. By connecting batteries together in a series, the voltage of each cell is added to the total electric potential of a circuit. Cells in a parallel. We can add more energy current without adding more voltage by adding the cell in parallel. We can add more, if we add more batteries, more cells into the circuit, we can increase more current without increasing the voltage. By doing this, the run time of the electrical device can be increased. The run time of the electrical device can be increased. Originally answers, what is the difference between current and power? That also should learn. Electric current is the actual rate of flow of electron past a given point in a unit of time. Power measured in watts is the amount of work electricity can do in a circuit. Watts are calculated by the voltage times ampere in a circuit. Okay, let's go back to the lesson. System of bulbs. Two simple methods of connecting several bulbs to a circuit are given in figure 10.10 A and B below. When bulbs are connected as in figure 10.10, it is called a series connection. When the connection is as figure 10.10 B, it is a parallel connection. This is a series connection and this is a parallel connection. Series bulb system. Let us do the activity 10.3 to study about series bulb system. You will need 5 element bulbs, 4 dry cells, 3 switches, connecting wires. Now the method. Connect one bulb with a switch and a cell shown in figure 10.11. Connect one bulb and the switch with the cell. Connect two bulbs with a switch and a cell as shown in figure. Now earlier we connected more cells and with one bulb. Now we are going to connect more bulbs with cells. Connect two bulbs joined in series to a switch and two cells as shown in figure 10.3. Switch on all the three circuits at the same time. These are called circuits. And circuit at the same time. And observe the brightness of the bulb. And observe the brightness of the bulb. Discuss with the teacher about the conclusion that you can come to according to the observation. According to activity 10.3, it is clear that the brightness of the bulb decreases with the increases of bulbs connected in series across a voltage supply. Brightness of the bulb decreases with the increases of the bulbs connected in series across a voltage supply. Now, in a series connection, if we add more bulbs into this, then what will happen? The brightness of the bulb will be decreased. So if you want to increase the brightness of the bulb, what you should do? Add another cell into this. But the initial brightness can be obtained by increasing the number of cells. Now, if you want to add, increase the brightness of the bulb, you have to add another cell. Thus, several low voltage bulbs can be lit from a high voltage supply when they are connected in series. Parallel bulb system. Let us do the activity 10.4 to study about parallel bulb system. 6 filament bulbs, 3 dry cells, 3 dry cells, 3 switches, connecting wires. Method. First connect one bulb to a cell and a switch as shown in figure 10.14. One bulb with a cell and a switch. Connect two parallelly connected bulbs to a switch and a cell as shown in figure 10.15. Now two bulbs connected to the switch and the cell. Now switch on. Now switch on all the three circuits at the same time. Observe the brightness of the bulb. The brightness will not significantly change even though the number of bulbs connected in parallel are increased. They all will light with almost same brightness. Now, brightness of the bulb will not increase, or even though if we add more bulbs, add bulbs parallelly, the brightness of the bulb doesn't change. They all will light with almost the same brightness. That's all. Let's meet again with the simple electric circuit.